Can you tell me what is common between a frying pan, a rope to hang your clothes, an airtight container, and a pair of slippers? Apart from the fact that they are all very useful in everyday life, another common thing is that they are made of a long chain of repeating units. In simple words, they are made of polymers. What exactly do we mean by polymers? As the name suggests, poly in Greek means many, and mer refers to units. So can we say many repeating units joined together? Yes, that's what it means. And these units are all the same. That means the basic units that forms the polymer will repeat itself several times. Do you know what this single unit is called? Yes, so it's called a monomer. A monomer repeats itself many times to form extremely long chains which form nothing but the polymers. Polymer can be naturally occurring or synthetic, which means man-made. Now can you tell me which among these are natural and which ones are artificial? Well, all of them are artificial. Yes, the frying pan has a surface of Teflon, the rope is made of nylon, the container is plastic, and the slippers are simply processed rubber.
Hi and Assalamualaikum, my name is IMAN SHAHFUDIN bin KARIM. So before we continue, I will give a brief review about what is polymer. A polymer is a chemical substance made up of repeating units or molecules to form a long flexible chain. This is actually a Greek word in which poly means many and mer means unit that refers to having many units. Each repeating unit called as a monomer. The process of linking the monomer together to polymer is called polymerization. For an example, in this chain, the first and the last mers are made stable by adding a hydrogen atom to the unused bind, and the plastic materials known as polyethylene will be formed. In engineering applications, we also come across the use of various types of polymeric materials. These materials are comparatively cheaper and already replace a lot of materials in our day-to-day life. They are corrosion resistant, low weight, and versatility in shape and size. Next, we will see the details about the polymeric materials.
Hi, my name is FATIHAH, and in this video I will tell you the behavior of polymer. So as we all know, every polymer is very resistant to chemical, light in weight, can be processed in various ways, and etc. The mechanical properties of a polymer involve its behavior under stress, whereas the thermal properties of a material is related to its conductivity of heat. So what are some of the mechanical properties? Number one is tensile strength. The tensile strength of a material show how much elongated stress the material will endure before failure. For example, this rubber band with higher tensile strength will hold a greater weight before snapping. Next is Young modulus. Young modulus is the ratio of stress to the strain in the linearly elastic region. And the last one is toughness. Toughness is the measure of the energy a material can absorb before it breaks. We can obtain toughness from the area under a stress-strain curve. And what about thermal properties? Polymer behave in an increasingly brittle manner as the temperature drops below Tg. But with the increasing of Tg, the polymer become more rubber-like.
Hi, I am SYAMIMI Aqmar, and I will continue with the advantages and disadvantages of polymeric material. So, polymeric material has a wide application which involves the use of commodity polymers as the structure. There are various configurations of polymer, and thus many advantages and disadvantages exist during the manufacturing. The first advantage is it has a high temperature resistance, which it can maintain its shape well at temperature between -40 degrees Celsius to 90 degrees Celsius. Polymer also easy to manufacture because there is no additional operation to produce the net form of a plastic part. Polymer is also a light substances which make its lifespan increases. From polymer, we can create another product that is impossible to build, such as clear and waterproof films. While polymer have many benefits, polymer also have limitations that make them weak. First, it is unsuitable for application involves high contact stress since it has a low modulus of elasticity compared to metal. Polymer also absorb water and expand due to the humidity. This will influence the polymer properties. Some polymer are flammable, which will produce poisonous fume when burned. Since polymer is non-degradable, it will produce waste to the environment if it is not decomposed properly.
Hi, my name is NARMATDEVI and today I am here to present the discussion part. So, for the discussion part, we have done some research about a recent scientific work which done on polymeric material. These surveys center on the most common materials utilized in biomedicine such as metallic materials, polymers and nanocomposites, including important application of nanoengineering in biomedical therapies and methods. So, as a result of this study, it can be concluded that the concept of nanoengineering as well as molecular dynamic simulations are extremely effective in revealing nanoscale corroboration data and subatomic communication throughout somatic and synthetic cycles which operate naturally visible properties behind side effects pursued by illness in the human body and device accumulation created by environmental factors. In the advancement of nanoengineering, the precision in displaying biomedical materials such as metallic materials, polymeric materials and nanocomposites is critical. So, nanoengineering has recently become a proficient methodology with a significant effect for biomedical applications, and it has also introduced extraordinary probable as the explorer innovation for upcoming peer group in this field. This survey, which is based on sufficient research, come up with vital data for a more in-depth understanding of biomedical progress. So that's all for discussion. Thank you.
Assalamualaikum, my name is NURSHAMIMIE binti HALIM. I take the part in deep analysis for this project, so I will illustrate the use of nanotechnology application for drugs transportation through the colon by nanotherapeutic polymer carrier and drugs transportation to colon via pH responsive polymer as their condition. Nanotechnology in engineering application is vital in the drug production and delivery system for biomedicine areas. The use of nanotherapeutic polymer materials such as PLGA, polylactic glycolic acid, the most commonly studied drug carrier for colon intersection through the GI mucosa in the stomach. The GI or the inner surface of the stomach is coated by a mucous membrane. Nanoparticles are solid, colloidal particles range from 10 to 1000 nanometer in size, consisting of macromolecule materials in which active ingredient is dissolved, encapsulated, absorbed or attached at the tissue cancer. So, polymeric nanoparticles which are sized in nanometer range protect drugs in vitro and in vivo degradation. So, this is how drug deliver to the colon via the polymer carrier.
Audio Jungle.